Hello everybody, my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science in UK based schools, and now I run a tutoring business where I've helped lots and lots of students get better grades in computer science related courses. And I've been trying really hard to get this assembly language lesson out before your test. If you are doing Cambridge International or AQA, this isn't going to be relevant to you. OCR people, if you need to get onto this website, you are going to go into Google and you're going to type in the little man computer and it's going to bring this one up. Just make sure it looks exactly the same as mine. This is a challenging topic and I'm going to just take you through all of the basic instructions and give you a couple of challenges that you can do in your own time. It is tough. It is really tough, this. And if you can just simply follow what I'm doing, it's going to give you some basic understanding of how assembly language works. And we're going to look at some different programs. I'm going to progressively make them more challenging. And it's going to be the way that you're going to break down this barrier of not understanding to understanding, write them down. Really interrogate. And what I mean by interrogate is think about what part of the code is doing what. That is so important. That is so important. It is, as a visual representation, I think it is very it's okay if you really understand what's going on and you've been doing it for a while. But there's lots of different things going on and it can feel a bit overwhelming, this. But the only thing I want you to focus on, if that's the case, is just focus on I can copy down what I'm doing. Yeah. If you can just do that, it's going to be better than doing nothing. So let's get going. So some of the basic instructions, we write the code up here. Basic instructions. We're just going to add two numbers together. First thing, I'm going to input in a number, INP. And then what I'm going to do is I'm going to store this in A. Store is STA. You can actually use STO as well, but STA. And then I put the variable that I want to store, which is, I've just called it A. I could call that whatever I wanted, num1, num2, whatever you want to call it. I input in a second number. The next line is going to be to add A. And then output this, and then I'm going to stop the program and I declare my variable at the end. This is a von Neumann architecture where instructions and data are stored in the same place. So what we need to do is we need to make sure we have enough space when we're creating this program. Works very differently to high level languages, which is where we store things at the start of the program and initialize our variables. We initialize them at the end. We can then click submit. I'm only going to do it slow once so that you can see an example, and it is showing you the fetch, decode, execute cycle. It is fetched an instruction and now it's going to tell me to input a number. Let's say that I do 10 and I'm going to add 5 to it. So we store that in the accumulator ready to be used, and what it's going to do is store that in position 6, which is the 7th, because obviously it starts from 0, 0, 1, 2, 3, 4, 5, 6 is 7, and you can see that 10 is going to position 6, so that's where it gets stored there. If you're looking at all of this and you're just like, this is just a load of colors moving around, do not worry. All you need to know is this block of code here what it does is it adds two numbers together. The visual representation, you haven't got that in the exam. Don't worry about it. It's start thinking to yourself, this is where you could maybe grab a couple of marks. If it's a really complicated piece of code, and the only thing you can remember how to do is add two numbers together, just write it down. Remember this, make a flashcard of it and say to yourself, this code here adds two numbers together. You never know, you might grab yourself a mark or two. So use it. Anyway, arithmetic logic unit adds the 10 and the 5 together. And then what it's going to do is it's going to put the 15 up here. Goes and fetches that. As you can see, it does take a little while though, doesn't it? And then 15 goes up there. Program is going to stop in a second. So first program, adding two numbers together. Make a flashcard, practice it until you can remember it off by heart. I'm going to stop that because the program is simply just going to stop. The next program we're going to have a little look at together is we're going to look at how to hard code. Actually, first of all, the two arithmetic operations you can do with this style of assembly language is subtracting and adding. So sub is subtract, add is add. So that's the next one. Another thing which is quite important is being able to hard code values into variables. So let's say that I wanted to hard code the number 1 into 1. So I put dat 1 and I hard code the value that I want to go in there. So because I've hard coded that, what that's going to do is that is going to that's 1 is going to be placed into this variable. I then, if I wanted to, let's say, input a number, subtract 1 from it, and then output it, I input 10, I subtract 1 from it, and it gives me 9. I have no idea why you would want to do that, but let's say it does. And then it's just going to do that, and it goes through, so 10, and as you'll see, it outputs 9. Okay, so again, that's how to hard code a value in there. So that's kind of another skill to your arsenal. So again, make another flashcard. How do we hard code values in there? Now, next part, one of the most important things that you need to be able to do in assembly language is make sure that you have the correct variable in the accumulator. The accumulator is where all decisions are made. So when we get onto BRP, BRZ, BRA, if you don't have the correct variable in the accumulator, it isn't going to make the correct decisions. So I know this sounds confusing, but it's important that we load the correct ones in there and the correct things happen at those moments. So if we wanted to load a value into the accumulator, this is how we do it. Let's say the program is that we want to input 2 numbers. Now at this moment, the B is in the accumulator. But let's say for whatever reason, I actually want to output A to start with. I put LDA, which is load A, and I output it. I LDA B, and then I output that. And then what I'm going to do is stop the program, and I just declare my 2 variables. Write it into yours. You can see mine's assembled all correctly. Try it out. Another thing that you can do, and this is, try and extending those programs. So maybe input 5 numbers and try and output them in all kinds of different orders. So start with the second number and output that first, and then the 5th, and then the 3rd, and just go in different orders, because that's going to build your understanding of how actually this LDA works. And once you understand that, I think that's probably one of the big things that I see people just not understanding, and then they can't answer any assembly code questions at all, is that they don't understand how to get the correct variable into the accumulator. And as soon as you can do that, then we can access some of the more difficult questions. Now, I know I'm trying to go through this as quick as possible for you, so just stay with me, keep writing the programs. What I want you to do now is we're going to go for a countdown program. So let's say I enter in the number 5. And what I wanted it to do is output 5, 4, 3, 2, 1, and then stop. And we're going to use a combination of BRZ, branch if 0. So if the count equals 0, we want to stop the program. And then otherwise, we want to keep doing what we're doing. And we can use BRZ and BRA together to create almost like a loop, a while loop, a conditional loop. So let's have a look at how we do that. Input in a number. First thing is store it. We then output this number. We are then going to subtract 1 away from it. And this is where we do our check. BRZ end. We want it to, so you put a label. And what happens is that is then going to jump to a point at where we also write end on the left-hand side of the program. I'll show you what that looks like in a second, but it runs a check and says, is the number in the accumulator 0? If it isn't, it's just going to ignore it and go on to the next one, which is BRA, branch of always, and we want this to loop back up to the top. We join the loops, join the labels, and we say, we want you to jump back up to here if your condition is true, which it will always be true if it gets there. So that's why you put the BRA afterwards, because it's going to do the check first. If that isn't true, it just ignores it, goes onto that one and jumps back up to the top. And then if it is 0, what we want to happen is end, HLT, stop the program. And then we're just going to declare our variable, so ADAT, and then we just need to hard code 1 in there. And as you can see, let's just quickly run this. I'll do it on the quickest mode for you, because I don't want to waste your time. So if I enter in 5, it's going to go 4, 3, 2, 1. Hard code, so you code this now, draw on it, what is doing what. Make sure that you fully understand each stage. And that is probably one of the most important structures that you need to be able to get, that this idea of being able to create a loop, jump around the program. Message me if there's things that aren't making sense. An extension question on this that I would recommend having a go at is trying to have a look at BRP, which is branch if positive, which actually I think it also accounts for 0 as well. But try with that program, if you input 2 numbers and you take one away from the other, output the larger of the 2. So think about how that one might work and see how you get on. So with this one on here, what we're now going to do is do one of the more complicated programs, which doing one of the more complicated programs is we're going to actually have a go at doing multiplication. Now, without the function of multiplication, if we have to break this down into the bare bones, which is essentially multiplication is where we add a number repeatedly to a total until a set number of times. So 3 times 2 is we add 3 to a total 3 twice, and that then gives us 6. So what we are going to do is we're actually going to use this countdown program to help us. So let's have a look at how we do that. We're going to input a number and we're going to store it in A. I input another number, store that in B. I'm then going to load total, which is 0. And I'm going to add the first number onto it, so add A. And then what I'm going to do is, so I load the total, add A. And then what I'm going to do is I need to store that in total. One of the big things I see from the examiner end is that people don't seem to understand that when you change something in the assembly language and then it doesn't automatically save the change. And so that works in both ways, is that people don't realize that that number hasn't been saved. Also, they don't realize that for them to save it, they need to say store that total. So that's a really, really important part there. Make sure that you do that. So we store that in total. So 0 becomes 3. And then what we need to do is we need to deduct 1 from the second value, so which is going to be 2. So we're going to load B, sub 1 from it, and then store that again. Remember, we need to change the value, so we store that, overwrite it over the top. Then we're going to store B, and then we are going to then do our checks. So we need to go BRZ end. If it's 0, if B equals 0, then it's going to stop the program. Branch if always, so our conditional statement, we want to loop back up to the top where we want to go to just the other side of total here. We want it to jump back up to there. Otherwise, we're going to want to run like our end procedure, which is where we load total, output it, and stop the program. And then I just need to initialize my variables, which is ADAT, BDAT, total, DAT. I guess you could set it to 0, but it doesn't really matter. It automatically does that. And then you've got 1 DAT 1. And if you have a look here, this should, so it's initialized all okay there. Let me run this really, really quickly, just with 3 times 2 so you can see it working. There you go. So extension problem, if you want to have a go at this, is how do you do division? Division without the use of a function is where what we do is we continually subtract a number away from another number. Do integer division, don't bother doing decimals. To repeatedly keep subtracting a number away from it and counting how many times until you get to 0. So that would be sort of a bit more of a challenge on that one if you want to give that one a go and let me know how you get on. So that is a very, very short look at how assembly language works, especially with the OCR version on it. And as I said, just, try some of the activities I've suggested. Have a go at just writing out. Inquire, run the program really, really slowly and think, okay, what's going on here? It's on this instruction, what has happened in the actual program. And as soon as you build that understanding and have that visual representation of, if I do this, this is what's happening in the CPU, that's when you start getting those big marks. Okay? Best of luck, people. I hope the exam goes well. Let me know how it goes.